Hello, pre-calculus. Welcome back. In this video, I'm here to talk to you about something that's actually very, very relevant to your lives, compound interest. So you might have heard the phrase compound interest before. It's used to calculate a lot of things. You use it to calculate a lot of times what you owe on a loan. So if you have what you owe on a loan. So if you have a loan for a car, a house, student debt, they're calculating your interest, which is the amount you owe on top of what you borrowed. They're using this formula to calculate compounding interest. So another thing that it can be used for is it can be used to calculate what you earn on savings accounts. And so that's the example I'm going to show you today. I'm going to show you how you could figure out how to save for college. Most of you know I have a tiny baby at home. She's not so tiny anymore. She's 20 months. She's going to be 2 in June. And so one day, maybe I want to send her to college. So we're going to use this formula and we're going to do a problem to show how realistic that goal is for my family. So here is our formula for compound interest. We have A of t is equal to P times 1 plus R over N raised to the N times T power. Let's go through each one of these pieces and talk about what it is and what it means. So A of t is the total amount of money in your account. This is everything you have in your account. So it could be either the amount you owe on your loan, or it could be the amount in your savings account. And we've looked at enough exponential functions right now that I hope you're looking at these next two pieces and you're saying, Sarah, I know what P is. P has to be my initial value. Sarah, I know what this junk in parentheses is. This has to be my growth factor. And if that's what you're thinking, you're absolutely right. So P here, P stands for principal. And that's the initial amount in your account. So if you start a savings account with $30, that is your initial account. So your initial amount is your P, is your principal. Or if you're talking about debt, that would be the amount of your loan. So if you took out $2,000 to buy a car, your P would be $2,000. And this thing I highlighted in red is your growth factor, but it's made up of a few different pieces here. Notice we have an R and an N, and that N actually shows up twice in the equation. So what are we talking about here? What's this R? R is your interest rate. So R is your interest rate. And you write it as a decimal when you use this formula. So make sure that you know how to convert back and forth from a decimal to a percent. That's a thing to look up if you're not so sure about that. And then we have also this value of N that actually shows up twice in the equation. This N is the number of times in a year that your interest is compounded. I'm going to talk about that a little bit more. You may or may not be familiar with it. This is the number of times in a year that your interest is compounded. What does that mean, compounded? I'll tell you. So when you take out your loan, let's say you take out your loan for $2,000 to buy a car. You owe the bank $2,000, and then they take interest on it. So they take interest and they take interest, and then you owe your $2,000 plus interest. But a couple of times a year, what they do is they add the amount that you owe for your principal, and they add the interest that you've owed, and they add those two together, and that becomes your new principal value. And that's called compounding interest. So it means that you're paying interest on your interest. So if you, like me, have a lot of student debt, I make student debt payments every month. but I'm just paying some of the interest, and I never actually get to pay down that principal amount. Not good. Not good, you guys. It's hard out here for your teacher. And then, you know what? I'm kind of joking and kind of serious. It is a little bit hard, but I'm in a much better position than I was when I was in community college, so I'm grateful too. Let's get this nice pink color here. We're going to highlight our T. The T there stands for time in years. So that's however many years we have is that T. So let's do an example. Let's talk a little bit. I told you I have a little baby. I don't want her to have as much student debt as I have. So let's do a real world example. Here, a pretty standard cost, there's a kind of savings account called a 529, which is just for saving for school expenses. And it's pretty standard that those earn 6% interest. You might have heard this called an APR. That stands for annual percentage rate. So 6% interest, and they usually compound twice a year. And that's pretty standard. Okay, this would be like your basic 529 savings account. These would be decent terms for your bank to offer you. I looked up online how much it might cost to go to college in 18 years. You know, she's 1 now, so I thought in 18 years, how much is it going to cost to go to college? My first Google result said it could cost $500,000 to go to college in 18 years. Yikes, right? Yikes. How are we going to get $500,000 to put the baby through college? So we're going to use this formula to figure out what I would need to invest this year, what I would need to invest if I wanted to get this $500,000 so that she can go to college. So let's take a look. We have our A of T is equal to P times 1 plus R over N, all raised to the NT. So we're going to use that formula down here with this information, and we're going to figure out how much money, what our principal investment should be. What our principal investment should be. Okay? So we have our A of T equals P times 1 plus R over N to the NT. So what I want to know how to get myself $500,000. That's the total amount I want to have in my account. So we're going to fill in that part with 500,000. And I don't know what the principal is. This is what I'm trying to solve for. How much money do I need to put in this account today so my little baby can go to college? So that's what we're solving for. That's what we're trying to figure out. Then we have 1 plus R divided by N. Well, I said that the interest rate here was 6%. But we're going to have to remember, convert that from a percentage to a decimal. So that's going to be 0.06, my interest rate. And what was N? Oh yeah, N is how many times you compound that interest. So I'm going to compound my interest twice a year. So we're going to have divided by 2 down here. And then up here we have N times T. So my time is 18 years. That's when I think she might want to go to college. So I'm going to say 2 times 18. And now I have to solve for my principal. I have to solve for P. And I'll show you guys how that works. It's actually not as bad as you think. So first thing I'm going to do is simplify my growth factor and simplify my exponent. I'm going to do those 2 steps here. So I have 500,000 is equal to P times 1 plus 0.03 raised to the 36th power. You could use your calculator for this step. That would be a fine use of a calculator, I would say. So I have P times 1.03 to the 36th power. And to solve for P, I'm just going to divide both sides here by 1.03 to the 36th power. This is the power of exponential growth. 1.03 doesn't seem like that big of a number, but when I raise it to the 36th power, we get something very powerful here. So this is what I have so far. I have my principal is $500,000 divided by 1.03 to the 36th power. And if you plug that into your calculator, here's about what you get. The principal amount I would have to invest is close to $172,000 and $172,516 invested today. And here's how I feel about that. Sad face. Sad face. That's a lot of money, you guys. So here's what I'm doing. Here's my financial advice to you. I am saving for my daughter's college education, and I'm putting in as much as I can. I'm not putting in nearly that amount. But I am saving for it. And I'm also hoping that the cost of college becomes more reasonable. That's a political hope. That's a political hope. Because I think that college should be attainable for working class students like yourselves, like how I went to community college. And you know, if I can't save up that $500,000, she can go to community college too, right? Okay, I hope that was a helpful example for you guys. And you know that you made a good financial decision when you decided to attend community college. You're saving a lot of money. All right, friends. I hope that was interesting to you. I think we're going to make a challenge problem about doing some more interest. Stay safe. I'll see you in the next one.